So you just watched Fight Club for the third time, and you've been doing BJJ, and you're really starting to make the next step and want to know how to make soap. So soap was probably discovered when people had clothing or animal hide, probably animal hide, that still contained the fat of the animal hide. And they were probably washing the animal hide in a river, and that river may be recently downstream from a mudslide or an ash slide. So there's like the water has a lot of ash or basic, it's an alkaline water. And then when they rubbed or broke in the fatty animal hides, the fat molecules reacted with the base, the alkaline river, created soap bubbles. Let's talk about that process before you actually start a fight club. Fat molecules um, this is meant to be like a rough sketch of what's called a triglyceride. There is uno, dos, tres carbon chains. Animal-based soaps will have animal-based triglycerides. Plant-based soaps will have plant-based triglycerides. So like you can make soap out of olive oil because it has plant-based triglycerides. And plant animal-based are going to be like different lengths, different amounts of saturation right here. This is the fat. This bond here is pretty weak, and the base or alkaline solution can very much break up this bond. And what you have in solution is this thing here, and then the these three guys produce. Let me put a, oh, here it is. Let me make this reaction arrow more prominent. So the base attacks this ester bond, and you have these things here. Now, these right here is what soap does its action with. What we have here is a molecule where on one side it is nonpolar. It has a long carbon hydrogen chain. It is nonpolar. And on the other side of the molecule, it is polar. What this does in aqueous solution are these individual molecules react with each other very well and form inside the solution. You could think of them as almost little Death Stars. And I use the Star Wars reference Death Stars to get the idea that it is spherical, but there's still volume, there's open volume on the inside. This is meant to be the hydrocarbon chains pointing in. And the polar side of the molecule is on the outside. So I'm just going to lightly kind of sketch a circle here because of my drawing skills. So don't imagine a circle, imagine a sphere with like a hole on the inside right here. So this would suspend inside of the water solution. Water molecules would be attracted out here. Oil, dirt, and grease is attracted to the inside or finds a way into the inside, or these molecules start attaching to it and eventually envelop it. Now, we just rinse the water off our hands and it goes down the sink. But these particles, like if say we washed our hands over a basin and collected it and then tried to filter it, like we would find like these particles in this. So these are suspended in that aqueous solution. They're called colloids. I hope this helps. Thank you.